Hello, my name is Socorro Vázquez Campos. I'm working in the Leitat Technological Center in Barcelona, and I'm leading the Human and Environmental Health and Safety group here. And we have been working for the last 10 years in nanosafety, and we run different projects, and our expertise are focused on the human and environmental impacts of nano-enabled products along the different life cycle stages of these products. And since 2013, we've been working on a project called GUIDEnano, and in this project specifically we've been developing a risk assessment tool, and this tool is composed by different modules that will cover the risk assessment of all the life cycle stages of a nano-enabled product, and you can also assess the human or environmental safety assessment of your nano-enabled products. In the following training session, I will explain you all the steps to run a case study within this software-based tool, and I hope everything will be then clear how to introduce your data and to do your risk assessment in your specific case studies. The GUIDEnano tool is a web-based tool for the risk assessment of nano-enabled products, and this tool allows the user to evaluate the human and environmental health risks of the nano-enabled product along the life cycle of these products. So this tool can be found in this website, and you will get a password, a user and password to get into the tool. The tool components is divided in different modules that we will go through in during the presentation of the web-based application. But here briefly, you can see that the tool is divided in different modules. So the materials module, which is linked to all the other modules, due to the characteristics of the materials along the life cycle are changing and interacting with all the other parts of the risk assessment. So then we have the activities, compartments, exposure and hazard modules that will allow the assessment to consider all the transformations of these materials along the life cycle into the module of risk assessment, where you get the output of your risks, considering all the endpoints in your case study. The tool considers, as it has been said before, the whole life cycle, so you can assess all the life cycle stages of in a case study, or just focus in one of the scenarios in this life cycle. So this makes the tool and the assessment really flexible for the user to be focused in one of the life cycle scenarios or in the whole life cycle. So then in the presentation about the web-based software, we will focus on the specific case study to show you how it works. And this case study is one specific scenario, which is the prediction of particulate matter emissions and workers' risk in a paint factory. And all the data is in this coming from this paper, and also from the safety data sheet that is about the materials that are considered in this case study. The data, the relevant data that we will use in this in the tool for running this case study is about the specific exposure scenario that we are focusing on. So pouring 10 small bags of titanium dioxide by workers in a paint factory. And then we have some input parameters that we will extract from the information that is described in this publication here underneath. So now I will get into the tool and show you step by step how to go and evaluate the risks of these workers in this specific case study. When you obtain your user and password, then you get to this web page, tool.guynano.eu. Then you get into the login tab, and you put your password here to enter. Then you get this screen, and then you get started with your cases. So when you go to cases, you can start your own case. Here we have a list of case studies that we have in already, but we will focus in the, as I said before, in the titanium dioxide case, pouring titanium dioxide in a paint factory. So when you click in the case, you enter your case or you create your case. And here you have the information. So to create one new case, you have to describe the name, as here is we call it titanium dioxide case study, and then you put a description, and the description is optional, so you can describe what is your case study in detail. Just to get back to that, you can put the authors, and then you also can put here a description of what you want to have in your final report, if you need some specific messages or identification that you have to put extra. Then once you have described your case, the title and the description, then you go to the next tab, which is the activity tab. So the tabs, as I explained before, is all the modules that GUIDEnano has in. So activities refers to the description of your scenarios and all the activities that take place in your case. And here the activity that we have is, so here you have the plus in the screen. So with the plus you can start describing your activities. So here you describe the name of the activity, then you say if it's a small or large industry, if it's a laboratory case study, and then the life cycle stage. Then you can put the different life cycles that you are specifically assessing. In this case, as you see, that for this case we are focusing on the production in a large industry, and it's a paint factory for pouring this activity that is pouring the titanium dioxide. And there is one location where it takes place. So this is all the information you should describe about your activity. And then you go into the activity itself, and here you have different parts of the to describe. So you have the general information, which is coming from what you described already about the case, and then you have the overview, which will be when you have all the other information filled in the different tabs. So when you go to the input and output and release, which is the main tab here in this activity module, And here what you have to be focused is on describing which is the material that you input in your case study. So here is nanomaterials that you are pouring into during the activity, which is titanium dioxide. And then the output, which is here in our case, is the output is the nanomaterial into a formulated paint. And then you also have to describe which are the releases taking place between input and output activity. The input, when you are in the activity describing your input, what is important here is the total amount of material. So you have here the material that you that is your input material. In this case is the titanium dioxide, and this you will see later that is what you describe in the nanomaterials module. So you have described there all the you have to describe all the components of your material and your material itself. So going back to the activities, so you have here already possibility to select your material that you have been described in this tab. So you select which one is your input. So in this case is the titanium dioxide, and then the total amount in the case study that we're running, we are putting the small bags, 10 small bags of titanium dioxide into formulator. So we have 10 times 25 kilos, so 250 kilos of, and here you have the units that you can actually say which are the metrics that you are using, if you have mass, particle number, or volume, and then you have the different units that you want to express your reference material. So you have one important thing, and this is why this number is highlighted, is that this amount is really an important amount for the whole assessment of in your case study, because is the amount that you consider a reference. So here you have to click that this will be the reference amount for your case, and then you have to type it here, and you will have that as a reference for your whole assessment. Then the rate is also important. So we have we are pouring these small bags, and each bag takes 1 minute to pour it. So we have this rate 25 kilos per minute. So once you already input this information, then you go to the output, and the output is also that we have titanium dioxide as the material as the output from our activity that is poured during the activity and it goes into the formulator, and 100% goes into the formulation. And this is the total amount that is related to the input amount that you feed it in. Regarding the release, then you have to describe which are the releases in your activity, and in this case you have emitted particles in the room, in the indoor room. So, and the particles that you are emitting during this process is the titanium dioxide material. So you have the release material described here, and then you also have to get this relative release and the total release for your assessment. So these numbers are coming from your libraries or from your measurements. So you have release values, so you have measurement done in this case in the paper we have this these numbers and we can input it here. So we have the releases. So here, when you go to this, so we have the units to express your release, and then the time also to get your rate. So you need to define the release time. So it's during the process of pouring, which is during 10 minutes. The 10 bags are poured in the paint factory, and then you can select, also indicate the way of release and the single activity cycles, how they occur. And then you have these defined to calculate your rate depending on your release, the total release. And then here it says, as you see, the overall mass balance is the outputs plus the release, and the input has to be 1. But here it says that it's not happening. And why is this? It's because if we go to local controls, we know that in this study, and this is a description that we get from the paper, that they use a local control. So they have a fume hood, so we put it here, we insert here the fume hood is in the room. So then this has an input to the release, because we have a local control, and that will be taken into account then here, because you have risk management measures applied, and that's why this is not counted here as equal to 1. So continuing with this module, we have also the tab on describing the duration of your activity. So here you have several questions to answer, and it's about the activity, the repetitions of this activity, the operational time, and also the time span. So the time span of all activities in the cycles together. So here in the particular case, the activity is applied once and repeated a fixed number of times. So you select this option. For the same batch, only one time is the activity taking place, and then we consider that this activity is operational during 24 hours a day, so 1 day operational time, and the time span is all the cycles are taking place in 20 minutes, considering the time of changing from one bag to the other of 1 minute, and then 1 minute pouring, so 20 minutes in total. And here you have all the information about the duration of your activity. Then in the nanomaterials flow, here you can see that a representation, you can see the representation of of your input and output and release, so how they are connected. So you are putting these bags in a factory, and so this is the activity and how they are connected. If you have more life cycle stages considering your case study, then this representation will help you to see if you are describing correctly the connections between your activities. And as I said before, then here you can put and add your local controls and redirect this with the output, and then you have the efficacy value that some of these local controls are already integrated in the tool, so you can select them, and that will be in the future versions of the tool. You have these available for the user, so you have a drop down list where you can select all the local controls, and their efficacy values will be integrated already, so then automatically you will have these values here. The same goes to this release activity. So these release rate values, you can have a library behind, and this is one of the future developments in the GUIDEnano, is also to populate this library that we have about the activity cards, and that will allow the user to select a specific release description or the release scenario, and then it will have associated a release rate that you can actually include here, and then automatically you have the assessment to much easier way to assess if you don't have that value measured. So once you have all this information inputted into your activity, then you have an overview of your what you fill it in this module, and you will have all this overview that allows you to see if something is missing, what you want to describe about your activities taking place in your case study. In the nanomaterials module, so we go to the third tab, so the nanomaterials module, and here, as you see, that you have to describe the different, the nanomaterial that is in your scenarios. And here, as I said before, we're focusing on the titanium dioxide. Then when you go here, we have all this information about the description of the properties of your the nanomaterial that you are considering in your case study, and you're considering to assess the risks on this nanomaterial. So here the nanomaterial identification, so you have the nanomaterial that you consider, and the description. You can add description that is coming in the safety data sheet, or in other description on the paper that you are, or in your measurements. And then you can select here if it's engineer, manufacturer, incidental, environmental, so you have different origin of your nano material. And then if you have the supplier, if you are focusing on a material that is coming from a supplier, then you describe here the supplier, so you have these options to have a more long description of what you are focusing on. Then you go through all the properties. Here you see shape, physical properties, surface properties, function, mass conversion, chemical info, reactivity. So all these properties are important to describe them because are really key for exposure and hazard assessment within the risk assessment process. So first, if you focus on the shape and size, here you see that you can start describing the shape of your material, which can be spherical, cubes, wires. So all there is all the possibilities here. So you select one, and then the mean size, and here the particle size, the diameter. Then you put here what is the mean size of your material and the aspect ratio. And if you have size distribution data available, so that we have here in this case, what we have is primary size, and we don't have the paper doesn't describe which method has been used. So we just put primary size, but you can use here this drop down list to describe your method which you use for this obtaining this primary size. Then about the size distribution, then you have here what we have is the mean size, which is 220 for this material, and the standard deviation that we consider this is an assumption that we have because it doesn't say anything in the description available, so we consider a standard deviation of 10% and a normal distribution. But as you can see here, you can give your nanomaterial size distribution by beans. So if you have this information, you can fill it in, and then your size distribution will be considered for your assessment. But in this case, we are focusing only in the normal distribution based on the mean size. And that's concerning the shape and size. Then the physical properties, you have to describe the physical state of your material, indicate also the category of the size. So here you have the different possibilities to categorize your solid material, and in this case it has been described in the paper as a ultra-fine powder, and nanoscale particles are in this sample that we are putting in the paint factory. Then you can say if it's rigid or flexible depending on which material you are focusing in. Here is rigid, and the dustiness, that we have this information from the paper and the measurements that are described in the paper. And then we have optional things that are the melting and boiling point, that in some cases are important for the assessment, and in this case we don't have this information. Then in terms of surface properties, we have to describe the surface area. Also this can be found in the paper, and also the some characteristics about the surface, so the surface charge, the zeta potential, the solubility, and the hydrophilicity and hydrophobicity of the material. And in this case the material that we have is a titanium dioxide, and it says that it has some impurities, and these impurities are described in the paper as alumina and zirconia, that are considered as a coating. And in this contact order section, what you have to include here is a number that shows how the order of your material respect to the core material. So the core material is the lowest number, and then all the other layers that are more in contact with the environmental or biological matrices, then they will have a higher number. So in this case the alumina and the zirconia are number 2, so it's in the out part of the core of the material, so in contact with the media, and they are considered as a coating. Then the surface charge is also information that you get from measurement that is described in the paper. So you have positive charge and the zeta potential as well. And then if you have material that is insoluble, high, moderate, low, insoluble, so you can here describe better the solubility properties of the different components. And then the hydrophobic or hydrophilic coating, then we can here in this case we have 2 hydrophilic coatings surrounding the core material. Then in the function, so the tool is allowing you also to describe which functionality is meant to be approached using this nanomaterial in the nano-enabled products, and In this case, for the paint, we are adding titanium dioxide as a pigment and as a UV filter function in the paint, in the final paint formulation. So you select that. Mask conversion. So here you select the matrix that you are using, that you want to express your amount of material, particle number, volume. So you have different possibilities that you can then get the output of your risk assessment in different metrics. Which mass unit we want to use, and here you can use grams, milligrams, kilograms, so we chose grams. And then here you can see the particle per gram that we have, and this number is coming from the mass that we already input in the first activity tab. And then also in per volume, then you can input your density value, and then with the density then you will get the possibility to get it expressed in volume units at the end. Then when you go to the chemical info, then here also you have that you can define the impurities, or if it's the purity of your material is 100%. So here you have yes or no for the impurities and contaminants, and then the purity of your material, you can type the purification that you have, the number. Here we have the purity of titanium dioxide is 100%, and then we have defined as 7% of coatings. So the reactivity here is the tab where you can indicate if you have this information about the reactivity of your material. So if dissolves, if it generates ions, or if it photodegradates. And here the information that we have about and that we are sure about it is that the titanium dioxide is photodegradates. So you can tick this reactivity to indicate this property of the material. Then the classification and labeling tab, where you can actually select from a list that we already have into the tool, and these are all the hazard statements that are in the labeling of some materials, and then we have to select which ones correspond to your material, if any. Then the toxicity studies, here we are not including these studies, but this tab will allow you to, in future versions, allow you to include studies if you have about toxicity that then will be used in the hazard assessment part of the tool. They will be considered for the hazard assessment. When you go then, well, here you have the quality assessment, and this quality tab, it means that it's evaluating all the information that you input in all these tabs about your material, which in this case is titanium dioxide. So you have the general data that you input, and if you have input them, then you have yes here, and then you have some. If you don't have some information about your material, then the quality is not 100%. So this factor is also then used for the similarity module that we have in the hazard assessment, because these allow to compare materials when you have them in your library, so you know the description of your material and the properties that are to be compared with a similar material. Then this is all the information that you have about your different materials that you have in your case study, and then you have to define all the constituents of your material. And here you have the core material and the coating material, which as it has been described in the paper that about this case study, we have alumina and zirconia as a coating, and then the core material. You can say if it's solid or liquid, if it's in this phase, and then all the concentration that you have, the different the core and the different coatings. So if you know this concentration, here it was an assumption because it has been defined that we have 7% of coating, and we assume that we have 50 of each of the coating components. So 3.5 and 3.5 of alumina and zirconia. And then when you define all the constituents and also the density here, sorry that you should enter the density for the units, as I said before. And then you have here the 3 tabs corresponding to each of the components, and for each constituent you have identification, so you can have the CAS number, the molecular formula, your description of your constituent, and then you have the physical properties. So also here the crystalline form, if you have defined the crystalline form in your case, or if you have this information, you can enter it here. And then the reactivity information as well. So here, as we said before, we know this material is photodegradable, so we put it here. And the classification and labeling, again, if we have this information, we can select one of these labeling identifiers. And then the quality, as said before, then is 100% quality, the information that you input. The same for the coating, so you have to define all these physical properties, the coating, the thickness of the coating if you have that, if this is coming from an engineer, from a matrix, from environmental or biological corona, and then in this case it's engineer because these coatings are coming from a synthesis process. And then if you have identified which of these groups your coating is belonging to, or your molecules that you have as constituents, then you select one of these groups. Or if you don't know, then you just select this first option. And then again, the reactivity information, classification and labeling, the same as before, and then the quality of the information that you input here will be indicated here, and the same for the zirconia. So all the constituents of your material, of the material that you have in your case study, should be described here as much as possible to be linked to the risk assessment later on in the flow of connections with exposure and hazard assessment. So then you have automatically this tab of presence is filled in by the tool. So you have all these materials and all the information about your input, output. So this tab is automatically already filled in by the tool with the information that you have in the modules before. So then you go you are ready with the Nanomaterials tab, and then you go to the Compartments module. When you describe the different compartments, then you describe here the name of what is your where is your indoor air. So you are in a factory hall, so then you go to the factory hall here, and then you can describe this is the general description, so this is already into the tool, but you can describe the characteristics of your well, the dimensions of the room, the surface of the room, height, all this information that you will have when you are in the occupational settings. Then you have all this information, and in this case we get this information in the paper. Then you have the zones, and then here is when you are in the factory hall, you have different zones. So the near field and the far field, which is the near field is close to the worker, and the far field is the rest of the room. And then you have the floor, if something is dropping on the floor when you are pouring. So these are the three zones that we consider in a factory, and you have to define here which is the media that you have in the different zones. So because if you are in the environmental describing environmental zones, you have different media that you have to consider. So in this case is air, and in the case of the floor, of course, it's the solid, and again the rest of the room is the air. And then the size, then you also get this information from the paper, and you can change the units as we say before. Always there's a conversion here possible, and here is the total dimensions of the room. And then each of the zones that you describe here, then you have the different the more detailed description of this zone. So the near field, you have the properties. So here is asking you for the temperature and pressure in the case of the factory. The composition, when you are defining that this media is the air, so you have this automatically filled in by the tool. So the tool has this into their database behind, and then you have the contact zones, and in this case for the near field we have the floor and the rest of the room, so the far field. And you have to describe the orientation of this respect to your zone, and how they are separated to the different contact areas. Then the emission tab, where you have already automatically filled in the release activity, so all the description on your activity tab, and the nanomaterial, and then all the amount and the time duration of the cycle. So here is you can select the different emissions in your zone. The processes, here you have also by the tool itself is filling in this information from your description of the different processes that take place, the emissions, and all the species that you have in the different parts of the factory. The chemical speciation is the same. It's all coming from the tool itself, and the kinetics is also a graph that is it can be inputted, and also for this case is related to the size of your particles and here is the titanium dioxide taken into consideration, with taking the time frame of 24 hours and 8 hours and 15 minutes. So this is the graph that is generated for your kinetics here in the tool. The tool itself is modeling that, and then the different species that you are considering, and here in this case is the core material, the titanium dioxide, and the type of who is exposed to this, and this is the workers, and exposed to the near field. So here is the description on the other tab of exposed populations, that in this case is workers. So we will go through that in the next module. So if we go back to the factory hall and the different zones, so we have all this information about each of the zones. So the same for the floor and the same for the rest of the room, which is the far field. And then we have, when we have this information about the different compartments considered, so the same for the outdoor air, the same tabs will be also asked to be filled. And then you go to exposure, and then here you go to the species that you want to consider in your assessment. In this case we are talking about human population, because it's the worker exposure that we are focusing on. And here is you define here that you are focusing on the workers in the particular case study, or you can select other population that you are considering. Then when you go to these workers, and here you have the different tabs to fill in information about the population exposed, which is the workers. And here again, if you already have this information, then you fill it in about information about the worker, how many work weeks a year, work days, body weight, all this information that might have an input in your risk assessment. Then the available protective controls, so you have a wizard that you can select the different PPEs that your worker has included during this activity or not. And this in this wizard you also can the selection of each of these PPEs will have connected to an effectiveness value that then can be filled in here, and then will be considered for the assessment the use or not the PPEs. Then the exposure paths, and here you have already the different zones that you describe in your compartments, and then you have to define which route you consider in each of these zones, so inhalation, dermal or oral, and the relevant material, the exposure relevant material that you have in each of these zones and routes. So in this case we are including the titanium dioxide as a material relevant for the exposure. When you this is the indirect through the zones, then you have also possibility to indicate if you have direct contact, and then in here then you have the different inhalation routes and to to define the concentration, the protective equipment use, and the population that is present. So this indicates the different characteristics of the different zones. So the here we have inhalation, and then we have the different values for the concentrations of this material in the different for this route. So this is calculated by the tool, and then we can select the personal protective equipment use, and then also the population that is present. So also the duration of your activity is here, and is coming from all the different information that you give in the different tabs before. So you can input it, and automatically gets filled in. And then you can see some graphs that help you to understand what you were filling, and to see if you are correctly inputting your information. Here then you have the different the other inhalation. So the other routes are also in the same way. Here you have to get all the information from the different routes depending on the exposure. Here we select when the tool allows you to use the different exposure assessments. Either you input your values, or you can use external exposure assessment tools to get the exposure values for your exposure assessment. After the description of all the exposure scenarios, then we go to the hazard assessment. In the hazard assessment, you have one first step, which is the question about if you already have the DNAIL or the OEL values for your hazard assessment. Then you say yes here, and then you can input your DNAIL or your OEL value here, and the units, and then referring to the different, in this case for the long-term duration, and then you get the final risk assessment value. So here that you can see the graph representation, and also the here the icon, the green icon, where you focus your assessment. So it was in the workers, it was an occupational assessment of the workers, and in the inhalation route. So for this endpoint, so repeated dose toxicity, and for the inhalation. So you see that this is the consideration for this case study, and then here is the representation of your risk characterization ratio, and is graphically represented here for the different endpoints here. And when you have all the other endpoints considered, then you will have the full graph detailed with your risk assessment. One specific characteristic of the tool in the hazard assessment part is the similarity module that we start including in this version of the tool. So when you don't have your DNAILs or your OELs to input here in this step one, then you say no here, and then you will go through different steps, and the step 2 is what we consider our similarity module. And what is that? Is that we use toxicity studies from similar materials that are similar to your exposure material, in this case the titanium dioxide. And if you have toxicity studies from similar materials, and the similarity will be evaluated following different questions that are coming up in this step 2 from your study that you input here. So the toxicity studies, if you remember, there is one tab in the nanomaterial module that allows you to introduce the toxicity studies. When you're here, you have here the toxicity studies. So if you input here toxicity studies that you have relevant for your material, then automatically you will have here in the risk assessment, in the hazard assessment part, you can rely on those studies and start evaluating those studies to consider then if they're similar or not, and then you get a value of your calculation of your DNL based on these different steps followed by the tool itself, and getting back to the final value that is calculated via the different inputs that you consider in the step 2. But in our case, as I said, we have the DNL value for this study. So we want to input that value. So we put the units first, and then we put the number that we already have about that, and then you get your graphically representation of your DNL safety limit value, and then you go to your risk assessment, as I said before. Then you get these graphs, and this is the output that you get from this tool. So now I have to say that this from this evaluation, the whole process of your evaluation, you have here an example of workers' safety assessment and risk assessment in the occupational setting on this factory. But as I said, the complexity of your case study can be higher, and the tool should be able to cover all the complexity of your activities when you go through the different tabs and the different models, and describing specifically all the details about the exposure scenarios, the materials that you consider, the compartments that are involved in these activities, and then through the process of modeling your fate, exposure and hazard assessment, you will get a risk assessment output with the units that you have been defined, and you will have the quantitative assessment by endpoints. That's it. I hope everything was clear in my explanation about the different steps to go through the GUIDEnano tool. And if you have any questions, or if you need help when you are running your case study through the tool, please contact us in the address that is in the webpage tool.guynano.eu.